Before this part looked like this, it started as an oversized bar of aluminum. Anthony designed the toolpath, but now comes the hard part. Actually machining it without crashing, breaking tools, or scrapping the whole thing.
It's snowing in Texas, they break so easy. You'll find the error the hard way. So this part here, right now, it's just a model on what we're gonna cut. That comes from engineering. Right now, it's just a bar. I think it's about 6-7 inches, so it's a big bar of aluminum. We'll saw cut it, I'll program it. So my next step is a mixed bag of pulling that PDF file and seeing, hey, what's super critical? What do we gotta be careful with? And then I'll start orienting this part on my computer. It looks like a lot, but first step is make a circle. Cut a diameter, cut an inner diameter. Next step, maybe add holes. And before you know it, that part will start taking shape.
The first job is to hollow out the center. Not the most delicate part of the process, but easily the messiest.
Yeah, so it's almost done doing the second circle out. Now, if that were steel, I would stop this and probably blow it out. It's kind of like grass. You cut the chips and now it's mulching the chips. It's recutting cut chips. With steel, the cut chips are much, much harder. Aluminum doesn't care, so I'm not too worried about it. Get all the stuff out of there. And then try to carefully, without making a mess, just broom them chips. I mean, you see what came out of it. I mean, that hole isn't that big. But all these chips are pretty much from that area. And then something else I can do. It's snowing in Texas usually when you have aluminum. Let the fan do the work. So you can see with our rougher so far, took that solid mass of bar of aluminum and we roughed out a rough shape. Like I said, and you can see the pattern of the cut. So it drops in and it does kind of a circle spiral until it knows it's maxed out, and then it starts picking out these corners a little at a time. Now we have our big hollow cereal bowl, and it'll pick up right where I stopped today. So now it's gonna finish profile that rough profile, make it nice and pretty and shiny, and the size, more importantly. So now next step is the little notches on that part, those little shelf notches. Yeah, so the program now is calling out for the chamfer, which is the soft edge on the inside. Yeah, so now it's just breaking that razor sharp manufactured edge. It's going to be a softer edge. The next step's going to be tapping those holes. Whenever you tap a hole, you want to try to have a clean hole if you can. Get an idea on where we're at so far. What you see down here will get cut out on the back side. So this I don't care about at all. Just tapping those 4 holes now. Tapping is probably the most dangerous part because they break so easy. You can have a beautiful part and you know, one bad tapping operation, the part's no good. Okay, so it's taking that tab, it's winding it down at a pitch, and then back out at the same pitch. Yeah, I don't care who you are, any machinist, tool maker, mold maker, when you're tapping a hole and the program's done, and that tap is still there, it's a good day so far. So the next step now is gonna be that undercut, that little slit saw. This is a highly critical area, so I built in some clearance on this. We cut it small, we'll check it, we'll make adjustments. So it's definitely an area that you really can't miss. If you miss, it's a bad part, you gotta trash it. But it's cutting much better than I hoped. So I'll bump my feed rate from 20 inches a minute to 40 inches a minute. It'll go twice as fast. So one more step before it rolls. Now the fun stuff.
The remaining features wrap around the sides of the part. Reaching them on this machine would normally require multiple setup changes. So before the first cut, we made a modification.
Anything top view you can cut with 3 axis, the standard machine. But if you have something like these holes, you know, you can't get them from top view. We would then pivot through the holes and then pivot to the other direction and do other stuff. So the CNC right now, as is 3 axis, X, Y, and Z. This machine has a trunnion we're gonna put into it. What the trunnion does, it gives you an option for more axes. So it'll give you the option to put a part in, rotate a part in both A and C axis. So it adds 2 axes. This thing will pivot that part and then you can do a hole, and then it will rotate it and do a hole or anything. You know, it takes about an hour to get it in. Once you get it in, it makes the job 10 times easier. This is the trunnion right here. For starters, we get the machine cleared out, cleaned up. We put WD-40 on the table, make sure there's no bumps or boogers on there, and we get it nice and smooth. Same thing with the trunnion. Accuracy is critical, so nothing in the way, nothing underneath. So I'm gonna come towards you, and then you pivot the front, I'll steer out, and in. All right, easy. That's it. So I'll tell the machine that the trunnion's there. It'll then recognize the A and C axis, and from there it's kind of like a fifth axis, only a little cheaper. Our first big step though is getting this platter. So I roll this thing to 90 degrees, and now our job is to get the trunnion itself dead square to the table. So any variation of any degrees out of square, it could be 0.001 degree variation. You're not running through to X. You're not running at a perfect 90 degree rotation. So you see the indicator on 0 doesn't really move a whole lot. Got a little hole in the center of the platter, that's normal. You can see from one end to the other, it's almost perfectly straight. So now the next step is probing the trunnion. When the probe senses any contact, it'll tell the machine that. Kind of how you pick up center, pick up edges. You see that the probe's flashing, so it's looking for contact. It's allowing us to put a part anywhere on that trunnion, and it'll compensate for the mismatch from center.
With the top side done and the trunnion ready to roll, now it's time for the fun part.
It's also the more scary stuff. That's when things can crash. Yeah, because the trunnion's gonna swing around. It's gonna start clocking those holes that we saw. Your X, Y, and Z planes change when we're programming that, so mistakes are easier to make. You'll find the error the hard way. Now it's gonna come around and do all those holes around the entire profile of that part. That's gonna clock that. See it rotate in there? It's gonna do the counter bore. Now it'll clock. You can kind of see now, they added all of our eventually be tapped holes, they added counter bores. That's what the trunnion comes in at. That would have been a bunch of individual setups. So that did it all at one shot in the trunnion. Looks good, it's got the burr, but that's no big deal. This is the second to last step, which is tapping the 8 side holes. Up, reset, and now it's gonna re-clock. They still look dead on. Two more. And then the last step of this part here is doing 2 little notches on the sides. Good. That should be a finished part. So there are critical areas in this slot right here. It'll go upside down into another vise and just hollow the center out from the backside and establish the height. But by far, the hardest part is what you see right there. Sometimes they give you a headache. And when you get through the headache and you figure it out, that's satisfying. So that right there, that's -1 from nominal, and our print is ±2. So we are inside nominal. That is a good part, confirmed, checked, ready to go. What we do. Is that a Power Ranger?
This is American Precision Engineering. We make the stuff that makes the stuff.